Now I'll call this next thing combination exactlies. So here's the definition. Don't worry too much about this definition. Let's say X is a set, and let's say you split capital X into a bunch of pieces. So you've got this piece X1, X2, up to XR. That'll be a partition of X. So these are just pieces that you're splitting this original set X up into. Let's say gamma is this list. So I have the first piece, and then I'll have some number of objects I want to take from the first piece. Then I'll have the second piece, and then some number of objects I want to take from the second piece. Then this last piece, and the number of objects I want to take from the last piece. So I'll define combination sub k of x with this gamma up here to be all the combinations C. So C will be a subset of x. I want the number of objects in C to be k, and I want the number of objects that are in C and in this ith piece to be ki. So this looks a little bit complicated, but I'll show you an example in a second, and this will make more sense. So combination sub k of gamma of x. This is the set of the combinations of x of size k, where exactly ki objects come from xi. So here's how you count combinations like this. If you want the number of combinations sub k of x using this gamma, so you want ki objects to come from xi, you'll just multiply all these things. So you take the number of objects in x1. If you want k1 of those, you'll do n1 choose k1. Then you'll multiply this with the number of objects from x2. I'll write n2 for the number of objects from x2. You'll choose the number of objects you want from that set. Then you'll take the number of objects in x3. You'll choose the number of objects you want there, and you just keep multiplying all these together. Here's an example. Let's say an urn has 100 balls. So 30 are red, 50 are green, and 20 are blue. I want to know how many ways I could take 22 of those balls so that I end up with exactly 7 red, 3 green, and 12 blue. So here X is the set of all 100 balls. Let's say R is the set of the red ones, G is the set of the green ones, and then B is the set of the blue ones. So I'm trying to find the number of ways I could take 22 balls where I end up with 7 red, 5 green, and then 10 blue. And I'm taking these combinations from the set X. X is the set of all 100 balls. So if you want to count the number of combinations of size 22, where you end up with this many of each color, you'll just look at the number of red balls. There's 30 red balls. I want exactly 7 of those, so we'll do 30 choose 7. There's 50 of these green ones, so I'll choose exactly 3 of those. And then there's 20 blue ones. I want exactly 12 of those. And you just multiply these together. So if you look on the bottom, you can see that I've taken 22 balls. So I've taken 22 balls. Exactly 7 of those are coming from the red ones, 3 are from these green ones, and 12 are from these blue ones. If you want to know how many ways you could choose so many balls so that you get at least so many of a certain color, you could do something like this. So let's say an urn has 20 balls, 11 are green, 9 are red. I want to know how many ways you could choose 5 so that you end up with at least 2 green. So what I'm looking for is how many combinations of size 5 there are from X where the number of green balls is at least 2. So if I want the number of green balls to be at least 2, there's a couple of ways that could happen. That could happen if the number of green balls is exactly 2. That could happen if the number of green balls is exactly 3, or if the number of green balls is exactly 4, or if the number of green balls is exactly 5. So if I want to count the number of ways I could end up with at least 2 green balls, I'm going to split that into exactlies. So you could have at least 2 green balls if you have exactly 2, or exactly 3, or exactly 4, or exactly 5. And for each of these, I'm just going to use the previous formula to count the number of combinations where you end up with exactly so many green balls. So if I want exactly 2 green balls, there was 11 green balls. I'm going to take exactly 2 of those. There's 9 blue ones. I'm going to take exactly 3 of those. So I've taken 5, but I end up with exactly 2 that are green. Now I want to count the number of combinations where I end up with exactly 3 green balls. So these 11 that are green, I want to take exactly 3 of those. Of the 9 that are blue, I want exactly 2 of those. Now I'll count the number of ways I could take 5 balls and end up with exactly 4 green balls. So these 11 that are green, I want exactly 4 of those. Of these 9 that are blue, I want exactly 1 of those. If I want the number of combinations where I end up with exactly 5 green balls, of these 11 that are green, I want 5 of those. Of these 9 that are blue, I want 0 of those. So you would just find this whole thing. So 11 choose 2 times 9 choose 3. That should give you this number here. If you calculate this one, this one here, it should give you this number there. If you calculate this number, it should be this. If you calculate this number, it should be that. And you add all these together. And then here's the number of ways that you could take 5 balls. So 5 balls, where you end up with at least 2 green. So if you want to calculate an at least, if you want at least so many green, you have to split that into exactlies. So if you want at least 2 green, that'll happen if you have exactly 2 green, or exactly 3 green, or exactly 4 green, or exactly 5 green. There's another way to do that problem. What we did just a second ago is we did the problem directly. We added up all the ways where you end up with at least 2 green balls. So we took the number of ways you could end up with exactly 2 green balls, plus exactly 3 green balls, plus exactly 4 green balls, plus exactly 5 green balls. So I would call that calculating it directly. Here's a way you could calculate that number indirectly. So it's the same problem. This time what I'll do is I'll take the number of ways you could choose 5 balls, minus the number of ways that you could choose 5 and end up with exactly 0 green, minus the number of ways you could end up with exactly 1 green. So here's the total number of ways you could choose 5 balls. I'm going to throw out the number of ways where you could choose 5 balls and end up with exactly 0 green. And I'll throw out the number of ways you could choose 5 balls and end up with exactly 1 green. Because these are the only 2 ways you could not end up with at least 2 green. You won't have at least 2 green if you have exactly 0 green, or if you have exactly 1 green. And you can see you get the same number here. All I'm doing is I'm taking the total number of ways I could choose 5 balls, and I'm throwing out the ways where I don't get at least 2 green balls. I won't get at least 2 green balls if I have exactly 0 green balls, or if I have exactly 1 green ball.